not easily explain key clinical and epidemiological features. And so this suggests that early environmental exposures also contribute. Okay? And then we take it from the current opinion in pediatrics to that major scientific journal, New York Times. And this is an editorial by Nicholas Kristof, who's very well read, saying, do toxins cause autism? And basically, from this article, saying, yet they constitute a huge, the toxins, autism constitutes a huge national health burden, and suspicions are growing that one culprit may indeed be chemicals in the environment. So this is finally getting play. Chemicals, heavy metals, as one of the things that are contributing to this epidemic. And I would tell you it's not just autism. And you'll see me give you information for ADHD and asthma and allergies, and likewise the cancers and diabetes and obesity even, interestingly enough. But we're not going to talk about those others today. So now we get to what I was trying to refer to when I was talking about biomarkers, is the subgroups of autism. Or as myself and some of my colleagues like Martha Herbert, etc., have called the autisms. It's not just one autism in a lot of ways, it's really the autisms. And if we can subgroup them, okay, if we can put them into various subgroups, and remember, as much as I know many of you may like to have everything be very neat and orderly and put in here, here, and here, these subgroups have a lot of overlap, okay? So there's not just one, it's not like, okay, this is only one subgroup. A lot of times it's multiple ones. But you try to figure out which subgroups they maybe sit in and which ones are more important than the other. And what you'll see is there's a very strong GI or gut-brain subgroup. There's a whole immune subgroup, either with allergies or sensitivities, immune deficiency, where they actually may have recurrent infections and low immunity, versus the other way of autoimmunity, where they're actually, autoimmunity means you're violating the boundary between self and non-self. The primary, sine qua non, the primary function of the immune system has got to be able to differentiate between yourself and non-self. So you want to be able to attack a virus or attack a bacteria, and you don't want to attack yourself. What happens when your immune system starts attacking yourself? You attack your joints, you get arthritis. You attack your skin, you get dermatitis, because the dermis of the skin. You attack your colon, what do you get? You get colitis. So we put an itis when there's inflammation, okay? You don't want to do that. And in a lot of these kids actually have evidence of autoimmunity. Some of it's even to their brain, some of it's to their gut. So they're attacking themselves. That's not a good thing. So part of our job is to restore that immune balance. Okay? They have all kinds of infections, viral, bacterial, sometimes strep, sometimes what we call anaerobes, fungal like yeast and parasites. All these can exist, more than one even. So we have to be conscious of this as a subgroup. Metabolic subgroups with dysfunction of enzymes. Enzymes are these functional proteins that make metabolism, make reactions in the body work better. And they can be affected by many things, including toxins. And we see this in you'll see a lot of these things. I'm going to talk about these things. Remember I talked to you about mitochondrial dysfunction. Those are the energy centers that don't function properly, don't generate enough energy at the cellular level, and therefore you have cellular dysfunction. Hormonal imbalances, I'll talk to you about a couple of those, including thyroid. Some of these kids have thyroid problems, and they're hidden, and they're not they're not out there, so you get a regular thyroid blood test, and it looks normal. But yet they have all the symptoms of low thyroid, and it turns out that some of the toxins out there actually can either mimic thyroid hormone, they can affect the thyroid hormone receptors, and what's happening is that where you need iodine to make thyroid hormone, iodine used to be kind of supplemented, iodized salt, iodine even in bread. And a number of years ago, what did they do? They replaced iodine with bromine. And so kids take a lot of fluoride, quote, for their teeth. They're getting a lot of bromide in various food sources, as well as you'll see other chemicals in the brominated flame retardants that are put in kids' bedclothes and PJs and the bed coverings so they don't burn. So they're getting, and all the chloride they get in the water supply to keep it clean. So we're getting all these other things that may be competing with iodine and affecting thyroid. So a number of the kids have hormonal imbalances. talk to you about something called oxytocin as well at the end. Nutritional imbalances. Many of them have nutritional imbalances. They're deficient. Vitamin D, magnesium, zinc, selenium, some of the B vitamins, on and on. Toxins, heavy metals and chemicals, that's a very big subset. And inflammation. And a lot of these actually, like I said, overlap, and a lot of these may contribute to inflammation. So what I want you to take home, and there's certain pearls from this talk, is some of the commonalities that are suspected to underlie these, quote, autisms, are toxins, so the toxic subsets, heavy metals and chemicals. Oxidative stress, which are these reactive molecules, very unstable, that try to stabilize themselves by any way they can. And part of the process is they attack cells. They attack the cell membranes that are around the cells. They get into the cell, they attack the mitochondrial membrane, they attack other organelles, and they wreak cellular havoc, cellular chaos. And so we have to quiet these oxidative stress or oxidants with what would you think? These are oxidants. They cause oxidative stress. What is something you hear out there a lot now that people take a lot of in terms of vitamins? Antioxidants. Why do you take antioxidants? Because sometimes this oxidative stress, you have a lot of built-in ways in your body to deal with oxidative stress because you can't get away with it. If you have a fireplace in your house, or you go skiing and you have a fireplace in the ski chalet, right? That fireplace is going to throw off sparks, right? It does. You can't. So you have a grid or a grill, to catch those sparks, right? Well, in our body, we have mechanisms to catch the sparks, the oxidants when we, in our own bodies, in our mitochondria, like in the car, we burn our fuel. Why do we eat? You eat because you need energy. You certainly don't eat because you want to get heavy. You eat because you need energy, right? And we burn that energy. So we burn the carbohydrates and we make energy, but unfortunately, it's not totally clean. And as much as we want to have a clean burning system, just like we want to have clean burning cars, and look at the fireplace. You have soot. There's no way around it. And you get sparks that if you didn't have a grill in front of it, might come out and set the carpet or the rug on fire in the room. So we have in our bodies ways to catch those sparks. But sometimes those ways, those antioxidant enzymes and various antioxidant substances, molecules, are not enough. They're overwhelmed when the stress is too much. And you need to take some things in. Antioxidants, right? Who here has heard of antioxidants? Most people, right? You hear it. They're advertised. You're probably taking them. If you're taking a vitamin with vitamin C and vitamin E, CoQ10, you're taking antioxidants, okay? And lastly, inflammation also is very common. It's one of the things we think most of the kids have, okay? So what are some of those environmental toxins that are known to cause damage to children's developing brains and nervous systems? Heavy metals. We're not talking about heavy metal rock bands, all right? Lead, mercury, cadmium, arsenic, okay? And multiple types of chemicals, PCBs, chlorinated dibenzofurans, organophosphate pesticides, brominated flame retardants. I just told you about that. And that's a classic example. These brominated flame retardants are what I like to give as a classical example. And you'll see down here, by the way, for the doctors, all this stuff, this is not just from me making this stuff. This is all from the medical literature. These are all references to document all these things. This is all out there. But the key is that the problem is, this is in pediatrics, so this is definitely read, this is a common journal, but a lot of the journals may be toxicology, neurotoxicology, neuroinflammation, that maybe a lot of doctors don't have time to read. That's where I live in those kind of journals because it's important to help the children to understand these things. But the brominated flame retardants are very important because it's a classic example of the double-edged sword of technological advance. We don't want our children burning up if there's a fire. So you want to protect them. So you want their PJs to be safe. You want their bed covering, their mattress cover and their blanket to be safe. So you put these chemicals to retard the flame should there be a fire. The problem is, your child's a young child, how long are they sleeping? 10 hours a day? 12 hours a day? And during that time, they're exposed to these PBDs or these brominated flame retardants. And unfortunately, that's not a good thing. So you see the double-edged sword. It's not always so easy. Technology is really, really great, but there comes a price, and a lot of times we just have to balance that out. And one of the problems is the exposure to chemicals and heavy metals is not coming when your child is 1 or 2 or 3. It's coming very early on. In fact, it's coming when they're in utero. Okay, it's coming to that pristine fetus, that baby that you've just created, that union of the sperm and egg that starts to develop into this little embryo that eventually becomes the child that you deliver, whether it be 31 weeks premature. A lot of kids, especially if they're twins, may be premature, but we say 40 weeks, 37 to 40 weeks, or 42 weeks is certainly in the range of term. But all that time they're in utero, they're being bathed by this wonderful, the umbilical cord, and the mother is nourishing them, hopefully with love, and hopefully with all these nutrients. But unfortunately, also with all these toxicants. And this is a small study from 2005, the Environmental Working Group. This is a shocker. They evaluated 10 newborn babies born in the US in August and September of 2004. And they looked at their umbilical cord blood, okay? That blood that is, quote, nourishing and feeding the newborn, right? In that umbilical cord blood, they found a total of 287 different types of chemicals. And an average in each newborn, and in that umbilical cord blood that was feeding them even before they were born, 200 chemicals and pollutants. An average. Do you hear that? An average of 200 chemicals and pollutants, quote, nourishing that pristine fetus. And the toxic effects including their carcinogenic, birth defects, abnormal development, and toxic to the brain and nervous system. And here's just a listing of many of them. And mercury, there's those polybrominated chemicals, the PBDDs, the PBDEs, perfluorinated chemicals, polychlorinated dibenzofurans, again, remember I said all those halogens, organochlorine pesticides, the PCBs, and on and on. I mean, there's just tons of chemicals. So there's basically pure, unsuspecting, totally vulnerable newborn for maybe all the months. And it's not your fault. The mother is not doing it on purpose. It's just this is what's happening in our environment. When we look at fat cells, and I wrote my first book way back on the immune system in 1997, so I can't believe it's 13 years ago. And I remember way back then there was a study, they had done fat biopsy. They looked and you did a fat biopsy, and I think it was almost 100% had a certain type of chemical. I think it may have been styrene or toluene. But the point is that we have these things in our fat. We don't think about it, we don't realize it. But especially in more toxic environments. And I would say, look at southern China. Last year, usually I've been coming every year now to Asia. And the last couple of times I've been going to China. And when you drive through either in a car or a train through southern China, many of you I know have been there probably, it is factories. I mean, sometimes you can't even see. The air is so gray and thick. And what happens when that air is a south blowing winds and very heavy, and they blow that into Hong Kong. These are heavy duty pollutants. Where does it go when you breathe in? It goes into your body, it goes into your tissues and your cells. So this is a problem.